Hello everyone, in this video we're going to look at the harder simultaneous equations, which are called non-linear simultaneous equations. We'll explain what that word non-linear means in a moment, okay? But before we actually get into it, you need to remember, for this particular type of question, you need to remember how to solve quadratic equations. So remember way back when we looked at quadratic equations, we looked at how to put them into double brackets and then make them equal to 0 and solve it. And you might even remember this horrible, well not horrible, it's a beautiful equation, but formula, sorry, this quadratic formula. So you might remember that. Okay, we're going to be using a lot of that to solve these equations, and if you can't remember how to do that, it might be worth looking back at some of the earlier videos I made, which go through some of these examples. So it's really important that you kind of have a go at the remember how to do those. Okay, right, now what we're going to do is we're going to solve this simultaneous equation, a non-linear simultaneous equation, in a moment. Okay, the reason why it's non-linear, first of all, the things to look for is you might notice that this equation has got squares in it. Okay, and that means it's going to be like a non-linear. The ones we did last time round, like these ones here, didn't have any squares in. They're called linear equations. But these ones, they're called non-linear. So these ones are non-linear because they've got squares in. You'll never really have one that's got a cubic in, unless someone's decides they want to be mean and put one in. But you're going to have like x squared ones in, okay? And that's one thing to look for to recognize what working out you need to do. The method we're going to use today is called the substitution method. So it's called the substitution method, and literally substitution is so straightforward to understand, but people don't understand that we can do it with algebra as well. So for example, if I said to you a is equal to x squared, and I said to you x is equal to 5, okay, then how would you work out a? Well, you'd substitute it in, wouldn't you? You'd replace the x with 5, so you'd say a is equal to 5 squared, which would be 25. But the thing is though, you can use that substitution principle with anything. So for example, if you had something like this, if you had a is equal to something like 6x, but x is worth, I don't know, 5y, okay? What that means is, wherever you see an x, that's equivalent to 5 y's. So you can replace anywhere you see an x, you can replace it with 5y. So here's an x there, but I'm going to replace it with 5y. But the rule of substitution, especially with algebra, is you should write it in a bracket. So this would be a equals 6 bracket 5y, which would simplify to 30y. Okay, and that's substitution. And the thing is, though, substitution is great because you can substitute as many things as you want. So for example, if I had something ridiculous like this, a is equal to 3b, b is equal to 2y, y is equal to, I don't know, 4x, something like that. Okay, let's say 4x plus 1, let's go crazy. Then we can substitute as many places as one. So for example, this y here, anywhere there's a y, we can replace it with 4x add 1. So here's a y there, and we're going to replace it. So b equals 2. But remember, when you replace things, especially with algebra, you should write it in a bracket. So 4x add 1. I'm going to clean that up. So that's 8x add 2. I've expanded it. So now I've got b equals 8x add 2. So wherever there's a b, I can replace it with 8x add 2. So here's a b. I'm going to replace that. So a is equal to 3 bracket 8x add 2, and if I expand that, I get 24x add 6. And there is an equation that links a to x. See, it's really straightforward, but substitution is basically that. You're replacing things, and that's the method we're going to use to solve this, okay? So let's get into it. First of all, the x squared y squared one, leave that alone. Don't touch it, okay? Look at the one underneath. What we're going to do is try and get one of the letters on its own, okay? Now, it doesn't matter what letter you get on its own, the X or the Y. I try and get the easiest one to work with, okay, to get on its own. So I'm trying to avoid things like fractions, dividing by things. I want to try and get the easiest letter on its own, okay? Sometimes it's unavoidable. You can't get the letter on its own. It's not possible without division. So there's some annoying fractions. Then you're just going to have to do it with a fraction. But here, I'm going to get the y on its own because it's the easiest one. Okay, so the idea is you take the second equation, the one without the squares in it, and you try and get one of the letters on its own, the easiest one. So I'm going to get the y's on its own, that y on its own. So I'm going to get rid of the minus 3x by adding it to the other side, some basic algebra. So that means y is equal to 13 add 3x. So we haven't touched the top equation. We've rearranged the bottom equation to get one of the letters on its own. So we've got the y on its own. Now, by the way, just to show you, if I got the x on its own, I would have had to add the 3x over, then take off the 13, and then divide by 3. So I'd have a y over 3 minus 13 over 3. And look how horrible that is there to work with. Okay, this is so much easier to work with. So it's all about trying to get the easiest letter on its own. Sometimes, though, it's unavoidable and you'll have fractions. But we'll look at that probably more into year 11. We'll do some questions on this. Okay, so now you've got this. We're going to use the substitution principle. Because wherever there's a y, we can replace it with 13 add 3x. So in our top equation, here's a y. And we're going to replace it with 13 add 3x. But remember the golden rule, whenever you replace something, especially when it's algebra, write it in a bracket. So we're going to replace that y there in a moment with 13 add 3x. So let's write out the full thing though. So it's going to be x squared, which is that, plus bracket. I'm going to replace that y with 13 add 3x squared equals 25. Okay, there is our equation. Now, just to kind of explain why we're doing this, okay? Yeah, this equation at the moment, that on its own cannot really be solved. I mean, you can guess, for example, but guessing is only going to give us half the picture, okay? That really can't be solved on its own. But this equation can be because you're working with one letter only, okay? You're working with the letter x. I know there's squareds involved and stuff like that, but that doesn't really matter because we're working with x's, and the x's, because there's only x's involved, we're just going to solve it straight away. And we can do that. Okay, now, how do we do it? Okay, so first of all, we need to clean it up. Okay, when I mean clean it up, I mean like expand any brackets, simplify any terms, and that's what we're going to do now. So what we're going to do is expand this bracket here. Okay, we're going to do that first. Now, just remember, whenever a bracket is being squared, like that one, that means there's actually two of them. Okay, so I'm going to write it out in full over here, maybe in the margin. Okay, and I'm going to expand that double bracket. So I'm going to expand it here. So that's 169. That times that is 39x. That times that is 39x. And that times that is 9x squared. I'm going to simplify that as well. So those two in the middle give me 78. So 169 add 78x plus 9x squared. Okay, so that double bracket expands to that. So what we're going to do is we're going to replace that there with the expanded version. Now I am going to contradict myself. I said whenever you replace something, you should always write in the bracket. But because we're only adding this term, we're not going to bother because we're just adding it on. If it was taking away or multiplying by something else, then yeah, I'd probably write it in a bracket. But because we're just getting it squaring and add that, we're just going to whack it all together. Okay, I'm going to have to delete this stuff. I'm going to have to memorize what that was, by the way. Okay, so let me get a different colored pen. Okay, so it's going to be x squared add, what was it, 169 plus 78x plus 9x squared equals 25. Okay, so we've expanded the double bracket. Now we need to simplify. Okay, so what can we simplify? The x squared and 9x squared, we can make a 10x squared. I'm going to write this as a quadratic. So remember, quadratic goes squared term first, then the letter on its one letter next, and then the number goes on the end. So I'm going to put plus 78x in the middle, and then 169 can go here, and that equals 25. Okay, now remember quadratic equation. You might remember this from earlier on, but what do quadratic equations, because that's what we have here, we have the start of a quadratic equation. What do quadratic equations have to equal? They have to equal 0. Okay, that's the most important thing. So we need to make sure we get 0 on one of the sides of the equation. So what we're going to do is to get 0 on one of the sides of the equation is the best side is, and remember we try and keep the x squared term positive, which it already is. So the x squared term is already positive. So we're going to keep that there. We're going to keep all of that there. We need to get 0 on one side. So what we're going to do is subtract 25 from both sides. We're going to take away 25 from both sides. So that's going to give us 10x squared plus 78x plus, what's that going to give us? It's going to give us 144 equals 0. Okay, that's a positive as well. Okay, and this is your quadratic equation, which you need to solve. Now, let me delete some of this. Okay, so we need to solve, let me copy that up here. We need to solve this equation. Now, oops. The first thing I would do is, okay, I'll tell you what. What we'll do is, because all the numbers are even, let's half it, because we can do that. We're going to half everything. And even the 0 is going to be halved. Okay, so 0 divided by 2 is 0. But all of this half is going to give us 5x squared plus, what's that halved? That's 39x plus, what's that halved? 72 equals 0. Now, we're going to solve this equation by factorizing. Okay, so that means we're not going to use a calculator. We're not, I mean, you can if you want to. You could use this, this formula, if you remember how to use it, which you really should do, to work out what x is, and you'll get 2 answers for x. That's important. But sometimes these questions appear on non-calculator papers, so we're going to use the non-calculator method, which is to factorize it. What we'll do is we'll just guess on this one, okay? So there is a method, remember that first times the last and then chopping it in half and all that. I'll do that in the next kind of question, but on this one we're going to take a guess, okay? So let's put it into double brackets and take a guess. Now, what I do is I look at that first of all and think, okay, 5x squared. 5 is prime. So I know that one of them's got to have a 5x in and the other one's got to have an x in, okay? Then I look at 72 and I think, okay, what numbers multiply to 72, okay? Well, you've got 9 times 8, okay? And then you've got, what else have you got? So you've got 36 times 2, that multiplied to 72. And what else have you got? So you could have 18 times 4. You can have, okay, and you can have, what else can you have? 18 times 4, so I think there's probably more, but I just can't think off the top of my head at the moment. Now, which one? So these one of these pairs has to go here and here, and then when you expand it, it's got to give you that in the middle there. Okay, so I don't know. Let's see. What's it going to? It's going to give us. It's got to multiply to 39x. So maybe the 9. Let's do the first one. Maybe the 9 goes here, and the plus 8 goes there. Maybe, I don't know. I'm just thinking out loud. Okay, so let's just expand that. Let's see if that works. I only really care about the middle term at the moment. Okay, so I'm just going to expand that out. Okay, so 5x. Okay, no, this isn't going to work. 5x times 8 is 40x, and then that times those two times given 9x. That's 49x. That doesn't work. Maybe it works the other way around. Maybe I've got it the wrong way around. Actually, the other way around doesn't even work. It's worse, isn't it? Okay, so what were the other one numbers that we came up with? We came up with 18 times 4, didn't we? Does that work in any way? Okay, so 18 times 4. So if I put the 18 there and the 4 there, if I multiply out the middle two, actually, you know, it's probably best to write it like this: 5, 5x and x, and 18 and 4. So 5x times 4 is 20x, and x times that is 18x. Okay, that gives us 38x, not quite 39. Okay, let me think. Did I miss any numbers out? Because they don't work. 36 is too big. Oh yeah, I did miss one out. It was 24 times 3. Okay, so I bet that works. So it's probably going to be that one. So, okay, which way around is it got to be? 24 is quite large, isn't it? So let me put that one there and that one there. So let's write it like this: 5x 24 and x and 3. So what I do is I write 5x add 24 like this, and then x add 3 like this, and I multiply across like this and see if they add up to the middle number. Okay, so 5x times 3 is 15x, plus an x times that is 24x, and when I add them together I get 39x. So this must be the double bracket. Okay, so if we just double check the whole thing, it should be right. Okay, so if I multiply this out, 5x times x is 5x squared, so that times that is 5x squared, that time that is 15x, that times that is 24x, and that times that is 72. And lo and behold, the middle two give you 39x when you simplify it. So that's that. Okay, so what we have is the double brackets that make that expression. Okay, so these were the two double brackets that made that expression. And don't forget, we actually need to solve the equation. So we need to look at both brackets and think about what value of x makes that bracket 0. Okay, so the first one, x is equal to minus 3. Because remember, minus 3, add 3 equals 0. So that's minus 3 is one answer. But you always get two answers. So here, if we look at the second bracket, well, actually, sorry, the first bracket, if we make that equal to 0, how do we solve that? Okay, we add the minus 24 over, and then we divide both sides by 5. So this is it here, but let's convert that into a number. So what's that going to be? How many 5s go into 24? It goes in 4 times. So it's minus 4 and 4/5, or 4.8. Okay, so this is the other answer. Okay, now the thing is that all will become clear as to why there's two answers in a moment. Okay, let me delete some of this. So, okay, so we have two answers for x. So one of the answers is minus 3, but we still need to find the answer for y. Okay, now we go back to the start. Remember we had this thing here. Oops. Okay, y is equal to 13 plus 3x. All we're going to do is put minus 3 into that and work out our first value of y. Okay, so y is equal to 13, add 3 times minus 3. Okay, 13, 3 times minus 3 is minus 9. So it's 13, take 9, so that's 4. Okay, now that is one pair of answers, so you should really write those together. Actually, you really should write it like this: x equals minus 3, comma, y equals 4. Okay, that's one answer. And we need to find the other pair, so we need to use the other number. So x is equal to minus 4.8, so we need to plug that into this. So y is equal to 13 plus 3 times minus 4.8. Okay, so let's work that out. It's 13, that's going to be positive times a negative is a negative. So 3 times minus 4.8. Okay, so that's 14.4. Okay, and then 13 take away 14.4 is minus 1.4. Okay, so this is the answers. Minus 3 and 4 for x and y, or x equals minus 4.8 and y is equal to minus 1.4. And they're your two answers. Now, it's a good idea to check both answers work, but they should do. That's quite long-winded, isn't it, really? And that's why these non-linear simultaneous equations are really tough. But even if you use the quadratic formula, you should get all of those answers here. Now, just to explain why there's two pairs of answers. Why is that one pair and this one pair? It's because if you were to draw the graph of these two equations on top of each other, you'd get the following. You get this, okay? The circle of radius 5 is the equation of the top function. Sorry, is the graph of the top function, top expression. And the blue line here is the bottom one. But notice where they cross, okay? They intersect at the coordinate -3, 4. Shock. And then the other one, if you look at it very carefully, the x value is -4.8. And the y value is, what was, I can't actually read that. It's -1.4. Okay, so when you solve simultaneous equations, you're actually looking at where graphs cross each other. So this is the equation for a circle. This is the equation for a straight line. And where they intersect is where you literally solve this simultaneous equation. Okay, now I don't want to make this video too long, but what you could do is have a go at this question here. So pause the video and then I will reveal all the working out for it. So have a go at this, do it in your own way. If you think, you know what, I need to use a calculator, then I don't really mind at the moment. Use a calculator if you need to, okay? But don't guess, use a quadratic formula if you need to. But I want to see some algebra and let's see what you get right, okay? Okay, so this is the working out. So I rearrange the bottom one to get the x on its own because it's easier. So I've got 13 minus 5y. I replace the x instead. So 13 minus 5y squared. That expanded to 169 minus 130y plus 25y squared. Simplifying that gives us 26y squared minus 30y. 130y, sorry. Minus 130y. Plus 169 equals 13. Take away the 13 from both sides, turns the end into 156. Now, if you tried to factorize that, first of all, well done, because I couldn't do it. But then I noticed that I could divide everything by something. So first of all, I halved it, and then I noticed that I could divide it by 13, and then so on. So if you kind of simplify it, divide everything by a number, I think you can just divide everything by 26. So just divide everything by 26. You get the following simple equation, okay, which is a nice easy one. Now that one factorizes into y minus 3, y minus 2 equals 0. So the answers for y are 3 and 2, and the corresponding values for x are, if 1, y is 3, x is minus 2, and when y is 2, x is 3. And I really should have double checked that they worked, so I should do that now. Okay, and here's the working out. So these two here give us 13 for both equations, and these two here give us 13 for both equations. So they're the answers, and I hope you got that. Okay, these questions are a bit tricky, and I think the hardest part is solving that horrible quadratic equation at the end, okay, because there always is one. So options are use the quadratic formula, watch the video on factorizing. You could guess as well, for example, you can guess. So it's all about getting that quadratic into a double bracket if it's on a non-calculator. So let me know how you get on with this. So if you're finding it a bit tricky, I might do some work on quadratics with you as well to kind of help you out. But it might be a good idea now to have a go at some questions from Caboodle that I've stated on showing my homework. Thank you very much for watching, guys, and let me know how you get on with this, and don't forget to submit tomorrow's homework. Thank you, guys. Bye-bye.